So the first problem for applications, and I'm going to show you one problem with actually 4 parts. How many cubic inches can fill a can of soup with a diameter of 3 inches and a height of 4 inches? And they ask us to first draw a picture. So I'm going to do my best rendition of a can. And there's the height, which is going to be 4 inches. And then here is the circular lid. And I'm just going to show the circle on the top. Okay, so it is 3 inches in diameter. So it goes all the way through the center, and that diameter is 3 inches. And of course, there's another circle on the bottom. We just can't see it. All right, so 3-inch diameter. That looks horrible, but you can see what that is. Okay, so we want to find the volume. So the volume to fill the can, okay, the formula you can look on your formula sheet is pi r squared, which right there is the area of the base or the top, whichever one, that circle. But then you multiply it times the height, and that's what gives it the third dimension, the volume. So as we're going to put in pi times, and the radius, oh, we don't have the radius, we have the diameter. So the radius will be half of 3 inches. So that's going to be, we'll just go ahead and say 1.5 inches. So that's going to be 1.5 inches quantity squared, and then times the height, which is 4 inches. So let me get a calculator on here, and I'm going to do pi times 1.5 squared equals, what happened there? 1.5 2.25. I should have known that. So that's 2.25. And remember, we're also squaring the inches. So that's going to be 2.25 inches squared. And then times 4 inches. So now I'm going to go ahead and take 4 times 2.25, and then I'll multiply the whole thing times pi. So pi times 4 times 2.25 would be 9, I think, if my mental math is, yep. Okay, so that's going to be 2.25 times 4 is 9, and then inches squared times inches is inches cubed. So we're in the third dimension, and exponent of 3, that's exactly right. And now we're going to take 9 times pi, and we get 28.274. So I'm going to put approximately equal to 28.274, so that's going to stay as 7 cubic inches. All right, so then it says that the soup company only wants to fill it 80% full. Okay, so I'm going to look at this picture up here and just say that 80% full, there's the liquid, so down here, that's how high they want it filled, and we're going to say that's 80% of the whole thing. Well, here's the whole thing, so we're going to say 80% of 28.27 cubic inches will be how much liquid will be in there. Now you could do this, you could do 80 over 100 times x over 28.27, or we could do 10% and then multiply it times 8, or you can just make 80% 0.80 or 0.8 and multiply it times 28.27. I'm going to take that route since we haven't done that in a while, cubed. So we're going to say 0.8 times 28.27. That's going to be 22.616. So that is going to be approximately 22.62 cubic inches. All right, so that's 20 or 80%. So the other 20%, the other 5 point something, would be 20% of that whole thing. So we could have also done 20%, do 10%, and then double it, and then subtract that from the whole can there, and you would get the same answer. Okay, so then the last part that it's written down says how many liquid ounces would fill this can at 80%, which is that right there, if there are 0.554113 liquid ounces per cubic inch. So if we have 22.62 cubic inches and we multiply that by 0.55413 ounces per 1 cubic inch. Notice here now that I can put that over 1 and the cubic inches divide out. And I'm left with 22.62 times 0.55413, and then the units will be ounces. So we got 22.62 times 0.55413, and so that will be 12.534, so we'll just say 12.53 ounces. So that's how much would be in that, would be in that particular can of soup. Now, we have time, so I'm going to take that one step further, and we're going to talk about how much metal would be needed to make this soup can. Okay, so I'm going to turn my paper over here, and you can turn yours over, and I'm going to redraw the soup can with a 3-inch diameter, and it had a height of 4 inches. Okay, and we're going to get the total surface area to see how much metal would be needed to make the can. Okay, all right, so we're going to draw the net first. So we got to cut this piece of metal, the lateral face, and when we cut it, it turns into a rectangle. And we've got the lid, or the top, and there's the bottom, both the same size, and has a diameter of 3 inches, and we know it has a height of 4 inches. Okay, now here's where I keep talking about and saying you've got to show your work. So to find the total surface area, I'm going to put SA for surface area, we have to find the area of the rectangle and add that to the area of the top and bottom. And if we're going to do the top and bottom and they're the same, what we can do is just say area of the top and multiply it times 2. And that will give us the top and bottom since they're the same. All right, so to find the area of the rectangle, we know we have to take length times width plus the area of the lid. It's pi r squared is the area of a circle, and then we're going to take it times 2. All right, now this part, the length, if we want to call the length 4 inches or the height 4 inches, then the width would be this right here. So we're going to say length is 4 inches, and we're going to multiply that times the width. Well, we have to figure out what the width is. And if you'll recall, this width right here, from there to there, is the same length as the distance around the circle, which we call circumference. Okay? So we're going to say that this length from here to here is circumference, which is equal to pi times the diameter. So, and don't ask me why I put 31 up there. That's supposed to be 3, and well, that isn't. It's just an I, but that's 3 inches. It looked like 31 in. Okay, So when I do the circumference, I'm actually going to be taking pi times 3 inches. And if I do pi times 3 inches, so pi times 3, I get 9.424 blah, blah, blah. So we'll just say that is approximately equal to 9.42 inches. So it's going to be 4 inches times 9.42 inches. And I'm showing the work up here of how I got this length, 9.42. It's just really the circumference of the circle. Okay, plus now I got to take 2 times pi times the radius squared. So we got to remember that the radius is 1